Hi everyone, let's take a look at an example of a washer method problem for finding the volume of a solid of revolution. In this case, we're talking about the region bounded by the trig curve y equals cosine of x, the x-axis in between x equals 0 and pi over 2, and we are revolving about the horizontal line y equals 1. And we are asked to find the volume of the resulting solid. So go ahead and graph it on your graphing calculator. I've already gone ahead and done so and taken a snapshot of the graph for you. I did adjust my window a little bit. I did zoom trig the first time. This intersection right here where the trig function hits the x-axis, of course, is pi over 2. This is negative pi over 2 over here. Here is your horizontal line, y equals 1. And which happens to be our axis of revolution also. So if you take a look at the problem again, let's make sure we have the correct region that we are revolving. Oftentimes that's the hard part. Just make sure you have the correct region. So we want the region bounded by the blue cosine curve, the x-axis down here on the bottom, and between x equals 0, which of course is the y-axis over here on the left, and that x-coordinate of pi over 2. All right, so it's almost this triangular part that you see here in yellow. So imagine taking that yellow region and flipping it upward over that horizontal line y equals 1. So with a disk or a washer method problem, our representative rectangles, of course, are perpendicular to the axis of revolution, but they are not touching it. That is, remember, the big difference between a washer method and a disk method. So this is a dx problem because of the vertical orientation of our representative rectangle. And you can see that depending upon where you drew that rectangle, the hole is kind of bigger. So like over here on the right, you'd have a much bigger hole there than maybe over here. If you drew the rectangle over here, you have a teeny tiny little hole right in there. Okay. So if you think of the formula that we're going to build our definite integral off of, it's going to be pi times big R squared minus little r squared. So big R is the distance from the axis of revolution at y equals 1 to the far side of your representative rectangle. So big R is going to be this distance here. So let's go ahead and get an expression to represent that. So we'll use the idea of top minus bottom. So at the top, we're hitting that horizontal line y equals 1. At the bottom, we're hitting the x-axis at 0. So big R simply is 1. Now let's do little r. Little r is going to be the distance from the axis of revolution to the close side. Essentially, it's the radius of your hole. So little r, again, we're going to use top minus bottom. So at the top, it's hitting that horizontal line again at 1, minus, and at the bottom, it's hitting the curve, the cosine curve. So 1 minus cosine x is the expression that we'll use for little r. So now we just have to piece it all together in a definite integral. Remember that our limits of integration will have to be x values. So in this case, we're going to use 0 and pi over 2. So let's go back to the previous slide and we'll get it all set up. So our volume then is going to be the definite integral from 0 to pi over 2 of pi. And then remember we need big R squared, so big R was simply 1, minus little r, and we have to square that. As we said, it's a dx problem. You are most welcome to simply evaluate that in your calculator, and the decimal answer you should get is approximately 3.816.